when you use a for loop or a while loop, there is something called the break. Sorry, good afternoon.
So have you shared
it's
your
like
slide?
I'm breaching the protocol. Huh?
Have you shared have you shared your slide with
who? It's still the same slide.
anyone sharing the link we gave
yeah.
in it?
What's happening over here? So the break statement is simply used to break out of a loop. You know, if you write a loop, it has to religiously follow whatever you have written in that loop. But if you want it to, and whatever code you've written, it will not exit until everything is finished, right? Maybe if you say that, for example, this code, if you say that the loop should stop, if you say I is 8, and you keep on trying while I is more than 0, do something. For example, this statement, it will do for I to 10. But if you want it to exit prematurely, maybe when I is 7 or 6 or 4, that's when you use the break statement. So the break statement allows you to stop a loop. For example, if you have I is 8, and then you are checking as long as I is more than 0, print I is equals to I minus 1. If I is equals to 4, break. So without this if statement, what do you think will happen? It will print 8, it will print 7 without the for loop. Without the if statement, it will print 8, 7, 6, 5, 4, 3, 2, 1. Right? That's without the for loop. But here we are adding an addition that please, after decreasing the value of I by 1, check that I is equals to 4. If I is 4, break. So it will break out of the for loop. I think it's clear. I should not waste time here. And there is also next. Shikuma next does not break out of the for loop, but simply goes to the next iteration, isn't it? So without this if statement, what happens? For x in 1 to 15, without this if statement, if you say print x, it will print 1, 2, 3, 4, 5, 6 to 15. But if you write a condition inside that, please check if x is 13. And if it is, next. So it would skip the 13 and goes to what? 14, 15 before it exits. But if I should replace this next by break, what happens? It will print 1 to 12 and then exit the for loop. Yeah. So that's how it works. We'll look at functions. So you asked me about functions. So the first class. So we're treating it today. So a function is a block of code that can be called using its name. A function can also take parameters as input and return values. R has many built-in functions. We looked at many of them, like the print, the cat, the max, min, etc. And basically, when you call the function, you supply in some parameters. For example, the max function here. Yeah? It's a function that requires you to enter some parameters and it gives you something, isn't it? So basically, a function does something. You feed in some parameters to it and it does something for you, isn't it? For example, the max function, what does it do?
Give it a maximum.
Yeah. It gives you the maximum number here. I don't need, we should not waste time. Go here. Rest is a variable. Rest is a variable that keeps in the maximum of some numbers. And then we want to print that. So whatever is the maximum is kept in the rest variable. And then thereafter we are printing out the rest variable. Is that okay? So for example, I have rest is a variable that keeps in the maximum of some numbers. Let's say 3, 5, 7, 45, 6. You can't see? Yeah? So rest is a variable that keeps in the maximum of 3, 5, 7, 4, and 5, isn't it? And then thereafter, I want to print out what rest is. So if you do this, it gives you 45, isn't it? As the maximum, isn't it? So it means the max is a function that does something. What does it do? It gives you the maximum of anything, isn't it? If you take minimum also, it gives you the minimum number, isn't it? So we'll also learn how to write our own custom functions that do whatever we want, isn't it? Yeah. So how do we define our own function? It's very straightforward. In addition to built-in functions, you can also define your own functions and use them in your code. For that, we need to use the function keyword. So that's the function. Yusuf is function. That's the keyword. If statement, if, while, for. Function, isn't it? And then the function also has a name. The name of the function is how. What does it do? It accepts some parameters, x and y. And what does it do? It prints out the result x raised to the power of y, isn't it? Is that clear? We want to design a function, POW, P-O-W, the way R has max, min, print, etc. We want to also design ours, but we want to name it POW, not max. And what do we want the function to do? We want it such that whenever we give it two numbers, it should carry the first number and raise it to the power of the second number. Is that okay? That's just what this does. And if you understand this, you can do any other thing you want. So for example, you can say the name of the function is POW, and it should be a function, yeah, that takes in two parameters, x and y, and it should do what? It should have a variable, let's say result, that is the first number raised to the power of the second number, and then print out the result. Is that okay? So this is just a function that does something. But if you do this now, you only declare the function, but you've not called it, isn't it? Even if you run this, it runs, but you won't see anything. When do you see it? When you call it. You define the function, and then you call it. If you define the function, you are telling the computer, this is how I want the function to be behaving. And then if you are calling it, you are saying, okay, do something for me. For example, now if I want to say 7 raised to the power of 3, I'll just say power what? 7 raised to the power of 3, isn't it? Yep. And if I run this, I will see what? 3, 4, 3. Is that okay? It's clear? It's clear, huh?
No.
Yes, sir.
What if you put it in the other way around? The power comes.
Okay, very good. If the power comes, or yx, or no.
I mean everything is intact, but it's just that you need the power.
Okay, the power comes before the function. This one you should know the answer now. Can you what are I? Can you enter a room? Can you sleep in a room before opening it? No. I just want to.
Yes.
You
I
want?
feel like as if R is a little bit flexible, being that.
No. I run quotes run from top to bottom, isn't it?
Right.
Yeah. Let me modify this to PAWI. Yes? So in this case, I'm calling the function before defining it. But if you run it, it will tell you, I don't know what PAWI is. So the first thing is for you to declare that PAWI is this, right? And then if you call the PAWI, it will give you that it's 343. So let's do another function. Let's say a function that takes in two numbers, your UTME score and the post-TME, and it returns the aggregate. You know, if you do JAM, you have to sit for post-TME, and the final result is the aggregate, isn't it? And the aggregate is the average of the sum of the post-TME and the UTME divided by 2. So we can design a function that does that, isn't it? So that whenever anybody comes, we just ask him to give us the jam and the post-TME, and then we see the aggregate, isn't it? So what do you do?
Is it to the delete? Is the same, just write one, that's all.
So please, to make the class interactive, what do you do first? The first thing is to have a name for our function, isn't it? Give us a name. The name should be befitting. The name should reflect what you want to do. Your function should not be, you should not name your function power while it is taking average. You know, it will work, but it may confuse you later, isn't it? So give us a name. Eh? No, I don't like that name. Eh? No. Just a function that takes in your UTME and the post-TME and gives you the average. What? Aggregate. Very good. Or AGG, what? AGG, isn't it? And what do you do? The AGG is the name of the function, isn't it? So what do you do? What's next?
Function.
The keyword for creating a function, isn't it? Function. The function will take in how many parameters? 2. So we have A and B. Yes? And what will the function do if it takes in the aggregate? I don't know. Whatever implementation is done inside the curly bracket, what do? It prints what? The sum of A and B divided by what? Yeah, that's it. So if you do this, you have defined a function that takes in two numbers, A, B, and then it returns what? The aggregate. So if you do this now and you run it, you don't see anything in it. Why? Because you've not called it. You only defined the function, but you've not called it. So in that case, if I have a friend that has an aggregate score of, let's say, 307, it's a guru, and then the post-TME got 344. If you run this, it will tell you that sorry, there's a problem here. It should be A plus B first go, then divide by 2. Is that what?
A plus B? I did same thing there.
No, there is a problem. No. We have A plus B over 2, but then we close the bracket because that's 325.5.
But Daniel,
Yes, sir. Yes.
This 4 and 5 that you skipped, is there any?
No. R is space friendly. It doesn't matter.
Okay,
I can even declare the function here. I can even declare the function in the script and then come to the console and call the function, isn't it? If I come here and I change this one to maybe it's a dull student 188, and then 188, 189, or 192, 195. If I supply in another value, let's say 200, So who can tell me the main role of a function? If you were to go to an interview and you're asked the key role of a function, reusability, isn't it? We just declared the function here now, so ever, and we were applying it to Mr. A, Mr. B, Mr. C, Mr. D. Even you, if you come and you tell me your aggregate score, I'll compute the aggregate for you using the same function. All I'll do is to call the function and supply in your first jam score, isn't it? That's 246. Then the posterior mean, let's say 300, and then it will give you your average. A function and a script. They are not related. They are not two things.
Because most of the times when you go to our bloggers, you discover that people have codes that they are written and you just copy their linguistic and they run a particular data. So
the script. This is a script. Whatever you have here is a script. It can be any. It can contain function. It can contain any other thing, isn't it? Yeah.
So, can the function take more than one distinct?
Yes. He's asking, can the function take more than one argument?
Argument, yeah.
Anyway, let me explain the difference between argument and parameter, even though this may not be useful to you, but it's important to know. Look at it here. I said AGG 234 and 300. At the point of declaring the function, when you are declaring the function, those variables you put to represent the numbers that we supply are what we call the parameters. So in this case, A and B are the parameters of this function, while 2, 3, 4, and 300 are what? Are the arguments. Argument. But people interchange them casually. It's not harmful, but they just know the difference. The parameters are the numbers that were declared at the point of declaring the function, while the arguments are the actual numbers that classwork. Classwork. I say classwork, my friend. Turn face. Write an add function that takes in your year of birth and returns your current age. A simple function that takes in your year of birth as an argument and returns your current age. Simple, man.
Okay, it should be subtraction. Current year.
Okay.
Like taking your year of birth and what?
You are to write a simple R function, and the role of the function is that whenever you call it, you supply in your year of birth, and then the function returns in how old you are today.
Sorry, Monday is Piazzo. Okay.
So the function will take in how many arguments? What and what? It depends on how you code it.
Yes, current year.
It can take the current year
and year of birth.
and year of birth. But if you make it to be 1, then it will assume that it's only functional. No, you're right. However you codify it. Hello?
And also the parameters must contain more than.
Yeah, the number of parameters will denote the number of arguments you have. So if you are to name the function, what do you name it?
Age.
Let's see, age calculator, age computer, or age comp, and that should be function, then what? In brackets, you can see, you can just come here and see year of birth. year of birth is equals to whatever, but even though we come to, and then here we say current year, but let's say 2024 now, and this let's say 1998, and then the function should be to take in what your year of birth and what. No, this is just the current year. Or you can just have let's say A comma B. Doesn't matter. And actually, you now see current year is you now see let me not even waste time here. I can just see current year versus what year of birth, isn't it? In this case, it will be age is equals to what? Current year minus what? Minus year of birth. And then we print the age, isn't it? So if you do this, you just declare the function. But if you want to call it, what do? You see age computer. The current year is, let's say we are in 2024, right? And then born in 1998. If you do this, it will tell you that you are 26. If you call another guy, say age computer, and let's say it is in 2024 and he was born in 2024. Let's go into the future. By 2030, Yusuf,
yes, sir.
You will be 19, you'll be 40. Okay, is that scary? We are approaching the grave. Eh?
What about 50?
Are
we dead? You say life begin at 40.
Is that the case?
That's what they say.
I have another theory that says at 40 that's the climax. So you will just be declining.
It's not acceptable. You can always
Okay, I think it's clear.
Yes.
Let's take another example. Maybe the one that takes in how many parameters? Let's see. Yeah, maybe average. Cool. Average of 3 numbers. Average of 3. Average of 3 takes in A, B, C, and it returns AVG is equals to plus C and yes, sir, we did. Yes, sir.
Last one,
Yeah.
the last function before this one.
Okay. Okay, let me. It's not correct. What we wrote is not correct.
Okay.
So this one was the original.
You are just saying the age is equals to this age is equals to the current year minus what? Minus year of birth. And then you can print the age.
Doctor Maman recommended.
H comp. Here you are using calculator.
I've seen it.
So it's case sensitive, right? So let's say average of 3 is equals to, let's say, yes ma'am. Have you rectified that issue?
Yeah, rectified. Barang kopa. Dah makan kopa. His case sensitive. I Shiva was shy. Capital letter was should have been it small. One number I brought them. And I said, yeah, she is in it. What if announced but we can't define by men the Mukasai? In that she was then Munkarami that she I from HCOM I need to know function and the Mukai
So let's say this one will have A, B, C, isn't it? Yeah? And then it says AVG. AVG is A plus B plus C divided by 3. And then you print AVG. And then if you run this, Old problem.
3.
AVG of 3. Okay, no. AVG of 3 is. Okay, we've not called the function. Go. We've not called the function. So this should be AVG. So whenever we call the AVG of 3 with, let's say, 3 numbers, 56, 77, and 34, it should print out the average for us without any problem. Let's go back to our. So we've seen this. This is clear?
That's really clear.
Yeah, it's clear. We also have default parameters. You can declare a function with two parameters and decide to supply one. That's possible with what we call default parameters. You know, usually when you declare a function with 2 parameters, you have to supply in 2 arguments. But you can design a function to have 2 parameters, and you can optionally supply in either 2 arguments or 1 argument using what we call the default parameters. Now look at this. We declared a function pow that takes in 2 parameters, x and y.
Equal to 2.
But we now set the default for y to be what? To be 2. So if you supply in 2 arguments, if you supply in two arguments, it will go and replace these 2. But if you supply 1, it will assume that y is what? Is 2. You understand, right?
No.
Okay, this example, for example, what happens? Whatever you supply in, it gives you the average, right? Abi? And if I put 10 and 10, 10 and 20, that's 15, go? Isn't it? If I put 10 here, it will give me error, but it says I are supposed to give in two arguments, but you supply only 1 because in your function declaration you supply. But we also say you can put this to have a default value. Let's say 0. Do you understand? Huh? So if you supply in 10 and 10, it will go and give A to 10, B to 10, and that will be what? 10, right? If you give in 10 and 20, you have 20 plus 10, 30 over 2, that's 15, isn't it? But if you decide to just give only 1, what happens? It will assume that A is 20, B is 0, and then it will now say 20 plus 0, 20 divided by 2, that's 10. So that's how we use default parameters.
Okay.
So I have explained the difference between parameters and arguments. So some functions, there's what we call return value in functions. This is very important. Sorry? The default, okay. Look at this function. It's a function called AGG that takes in 2 parameters, isn't it? So when we want to call this function, we have to supply in 2 numbers, right? For it to work fine. So the average of 20 and 43 is 31.5. We now said, if you decide to supply in only 20, what happens? It will give you error because your function requires 2 and you supplied 1. So if you run this, it gives you error. It tells you that argument B is missing with no default. We now said you can decide to declare a default for B, and you can make it to be anything, maybe 10. So whenever B is not supplied anything, assume that it is what? It is 10. Yeah. So in that case, if you supply in 50 here, 50 and 50, or 50 and 40, that would be 90 over 2, that's 45, go. But if you refuse to supply in the 40, it will assume that B is carrying 10, and then you have 50 plus 10, 60 over 2, that's 30. Yes. So that's the default argument. This one is return. There is a difference between when a function is returning something and when a function is printing something. This one you have to be printing, yes. In returning, it means you can further assign whatever is returned in the function to another variable. When a function returns something, it means whatever that function returns can be assigned to another variable. For example, look at it here. If I say x is 50, I can come here and say v is what? Is x. Have you? And if I print v now, I see what? I see 50. But look at it now. This AGG, if you call AGG now, what does it give you? It gives you 30. Go. Have you? So let me come here and say, x is equals to AGG 50 returns what? AGG 50 alone, it returns what? 30. It returns 30. 30. Go. So I am now assigning the AGG 50 to x. Okay, please. What do you think if I run this now? What if I say x is equals to AGG 50, okay? And if 30, well, I get 30. If I print x now, what do you think will be the answer? Get 30. Eh? No, the AGG 50 returns 30. I am now assigning the AGG 50 to a number x. Ordinarily, it will give 30, but it will not give you 30. It will give you this 30. Let me say y is equals to. Let me say y is equals to x now, and then print x. This 30 is not the. Yes, sir.
This is return value. When you take us as function, please study
from the fundamentals. Okay, so let's go back to the. So in most cases, we want the value calculated by our function to be assigned to a variable instead of just outputting it. In these cases, we can use the return function to return a value from our function. For example, let's rewrite our power function from the previous example to return the resulting value. So for example, this, we're not using print, we're using return. Okay? And whatever we have here is assigned to A, and then we print A. Even though, ironically, even the print, so what we're saying is that we can just come and say here, return A plus B. Okay? And then in this case, if you do AGG 50, it returns 30, right? And then this AGG can be assigned to another variable. So you can come and say, okay, Yusuf is equals to AGG 50, and then you can go ahead and then do something with what? And print 30. Even though when you use print, luckily it worked, but in some other languages it will not work. It's just one of the friendliness of R, isn't it? In other languages it will not work. So even though the package is here is for another session, but you can just learn how to. as you analyze data in R, there are two ways to do that. There is what we call the base R, okay, and there's what we call libraries that assist you in doing that, isn't it? So whatever you want to do using some additional libraries, you can do it too. So whatever you want to do with additional libraries, you can do it using the base R. But the additional libraries make it easier for you, isn't it? So, and in R, there are several of those libraries. If you go to your R, you come to this place, you see packages. You see several of them listed alphabetically, isn't it? All of these packages have their functions, isn't it? Is that okay? So let's assume you want to install another library for doing something. Maybe you went to a forum and then a friend of yours gisted you about a library that's very fancy, and then you want to try it out in R. How do you install it? So it's very simple. You just come to your console and you type install.packages, okay? Then you write the name of the package in quotation, and then it will go online and install that package for you. So this is what I'm trying to say here. Collections of R functions, data, and compiled codes in a well-defined format. It extends the functionality of R and provides reusable code for common tasks. And if you want to install any package, this is the command: install.packages. For example, tidyverse. Tidyverse is a very popular library in R for doing data analysis. Yeah, and by default, it does not come with please let me pick this one. No? I'm not sure. Yeah, so ordinarily, if you come to this place, if you want to verify whether a library is there, if you come to packages and you type it, tidyverse, for example. Me, I have it already, so you see it there. But for you, try. Let me see. Go to packages and try tidyverse. Nothing is coming up, huh? So, but now come to this place and type tidyverse. Go to your console and type tidyverse. Ensure that you are connected to the internet. Are you connected to the internet?
No, I said that's very important.
Okay, yes. Sorry? I don't have Agricola. It's library for what? I don't have it. It's a popular library for doing. Okay. We use the base ones: tidyverse, bpila, ggplot. You just hit enter.
Warning, R2 is required. Wait.
Sorry?
He's bringing too much currency.
Function and return.
Jaja currency there.
Function and return. The function of return? Return enables you to be able to supply in whatever your function outputs to another variable. Sally, let me just do it della for. If I come here and I say A plus B, if I say A plus B, will this code give you error? It will not give you any error, isn't it? Have you? It won't give you any error. But now if you say x is equals to, if you come here and you say x is equals to AGG 50 and you print x, I don't know, this example is still confusing. Let me come here and say let me say print Yusuf, print programming, okay, and then return, okay, let me say print A plus B, okay, and then return A raised to the power of B. Okay? Can you see this? I have a function called AGG that takes in two numbers, A and B. The first thing the function does is to print Yusuf. Then it prints programming, and then it prints the sum of A and B, and then it returns the what? The product, the A raised to the power of B. So let's try it with 50 and 2. So what will be the output? We'll see Yusuf programming 52 and 2500, isn't it? Yes. Abi? If you call this function now with 50 and 2, it will print Yusuf programming 52 and 2500. Cool? It prints Yusuf programming 52 and 2500. Now, if I say x is equals to this AGG 50 and 2. Cool? If I print x now, what will be the answer? X will not print use, it will only print that return, that result that was returned. Again? It's clear. This one is plus, this one is minus, this one is times, this one is if you run this one, it will print what? To print 52, 48, 100, and then 2500, isn't it? Abi? Yes. But if you decide to say, okay, x is equals to this AGG 100, isn't it? And then you say print x now. It will only print what? The returned value. What will happen if I come here and I say if I return this, what happens? What will be the output here? What if I run this one now?
Still the same thing. It will give me 52, 48, 100, and 242. The return as well.
It will print program, then what? 48, no? That's 48. Then what?
A times B, that is 100. A 50 times 2 is 100.
If you write a function and you say return, anything that comes thereafter is useless. It's useless. That's the last entry point for any function. You understand? Let's try it and see. Can you see? It printed program and then 52. As far as it's concerned, anything that comes after return is nonsense. Can you see that I wrote a nonsense function here? Eh? Print. Or I write some Jogolo. Ordinarily, it should give me error. But because the function does not even go beyond it, so it doesn't even know it exists. Do you understand? It's clear, right?
Yes.
Just like a 0 after a small point is useless. So any statement after a return statement in function is also useless in programming. So on a normal day, I don't know whether you're having conflict with this, but if you install this, it should install the tidyverse package for you. And then if you want to load it, you can just say library tidyverse. And then from there, you can be able to use all the available libraries that come together with it. This is a topic for another day. Even if I teach it now, you don't understand. We have to get the base art first before we can now appreciate this one. So at this juncture, we'll move to week 2.